Work and energy, class 9. What is work? Work is the displacement made by applying a force. The formula for work is force into displacement. It is a scalar quantity and its SI unit is joules. The value of 1 joule is F into S, which is 1 Newton into 1 meter, which is 1 Newton meter. So there are two types of work, positive work and negative work. So let's see positive work. When I have an object here and I'm applying a force in this direction, if the object moves in the same direction of the force, it is positive work. Or when the object displaces in the same direction of the force, it is positive work. And when, let's see, negative work, I have the same object and I am applying a force of F in this direction, and from the opposite direction someone else is applying the force of 2F, which means it is 2 times the force I am applying. So I am standing here and the force which is getting applied from the right side, or 2F, is greater than my force. So the object will move in this side, which is opposite side of my force. So therefore, for me who is standing here, I am applying the force on this side and the object is displacing on the opposite side of the force. So this is negative work. Coming to energy. The energy possessed by an object is measured in the terms of its capacity of doing work. Energy, its unit is joules. It is a scalar quantity and 1 kilojoule is equal to 1000 joules. Coming to forms of energy. There are many forms of energies such as mechanical energy, heat energy, chemical energy, electrical energy and light energy. So let's see mechanical energy and its two types. First is kinetic energy. Objects in motion possess this energy. This energy is known as kinetic energy. So objects who are in motion or who are moving possess kinetic energy. And potential energy is the energy due to the position of an object. Coming to kinetic energy. Kinetic energy is the energy possessed by an object due to its motion. It depends on velocity. If the velocity is doubled, then the kinetic energy will get 4 times. Which means that if I have a ball and I am throwing it with a force and my velocity is, let's say, v. So the force is not enough to break a glass and it will just make cracks on the glass. But if I increase the force, my velocity will also increase. So the increased velocity can break the glass and either make a hole in it or crush the glass. So the derivation of kinetic energy. We know that force can be written as mg or ma according to the second law of motion. And when I am taking gravity, so I will take acceleration as acceleration due to gravity g. So my force will be mg. So applying the same formula in the formula of work, which is force into displacement. So I will take m into g, or mass into acceleration due to gravity, on the place of force. And for s also we have a formula, which is 2as equals v square minus u square. So here I can take s is equal to v square minus u square upon 2g. G, why? Because we are taking gravity, we are considering gravity. So let's replace these all in the work formula. So I'll get w equals mg into v square minus u square upon 2g. G and G will get cancelled and I'll have the formula for work as mass into in bracket v square minus u square whole divided by 2, or I can simply write as 1 by 2 into m in bracket v square minus u square. So this is the formula for kinetic energy. Why? Because we are involving velocity here. And why is it written as half mv square only? Because when we consider kinetic energy here in this chapter, we are considering u as 0. So the object is moving in a uniform velocity. Okay, it is in a uniform velocity. So when in uniform velocity, it will have the same velocity overall. Thus, the formula for kinetic energy will be half mv square, where u is equal to 0. Coming to potential energy. Potential energy is the energy due to the position of an object. It depends on height and mass. Work done by gravity depends on the difference between vertical heights and the final position. So let's see what it means. So first let's derive the equation for potential energy. So again, work is equal to force into displacement, and force I'll take mg. And when I am talking about potential energy, I'll talk about height. Why? Because it is the energy possessed by an object due to its position. So position means height, right? So I'll multiply mg by h. So I am getting the formula as potential energy is equal to mgh. Okay. And one more thing, that if I have an object on the ground here and I am raising it over here, so this is the height h and this is the path I have taken to raise it, right? And if I take the same object and I raise it like here, taking this path, if I raise it to the same height, I am raising the object to the same height as of the previous height, the potential energy will be same here. Why? Because you can see that height is involved, means this is h1 let's say, and this is h2 and this is h3. So in this case we can see h1 plus h2 plus h3 is equal to the total height, which is h. So law of conservation of energy. Energy can only be converted from one form to another. It can neither be created nor destroyed. So if I take an example of, I have kept an object on the mountain. So here we'll have the highest potential energy because of its height. Right? Because height is the highest, potential energy will be also the highest. So the sum of potential energy and kinetic energy, let's take it this way. Yes, the sum of potential energy and kinetic energy is known as the total mechanical energy. Total mechanical energy. So the total mechanical energy always remains constant. How? Let's see. So coming back to the example of mountain and object. So at this point the object has highest potential energy because of its highest height. So if I start taking the object below, like if I take it here, and obviously the object will start falling down, means it will have kinetic energy. Why? Because it is moving. So Here the potential energy was highest, and while coming down on the ground level the height is 0. Therefore potential energy will also become 0. But here the kinetic energy will be the highest. So in this way the total mechanical energy is maintained as constant. Coming to power. Power measures the speed of work done. It is defined as the rate of doing or rate of transferring energy. Means how much work is done in how much time. So therefore, the formula for power is work upon time, which is watt. The SI unit of power is watt. It was discovered by James Watt in 1736 to 1819. He was there. So 1 watt is equal to 1 joule upon 1 second. So therefore 1 kilowatt, which is equal to 1000 watts, will be equal to 1000 joules per second. So therefore this is all the formula for power. And how to calculate average power? We can calculate it by total energy upon total time. Commercial unit of energy. So we cannot take bigger units of energy in the form of watts. So therefore we have kilowatt hour. Right? We cannot take the amount of power of seconds in every time. There are numerous buildings, numerous houses in this world. So we cannot measure second to second. Therefore we have kilowatt hour. So 1 kilowatt into 1 hour gives us this unit. So 1 kilowatt is equal to 1000 watts into 1 hour, which is 3600 seconds. So therefore this will give us 36 lakh joules. Right? So therefore 1 kilowatt hour can be written as 3.6 into 10 raised to 6 joules. Thank you.